Alright, time for another DraftPhysics.com, DebatePhysics.com, but no reasonable, useful, in any form of kind of constructive would be a very good word. No constructive argument and counter argument. So we just have to, mush along until somebody with a brain that can articulate and say something meaningful and useful shows up. But so far, nobody can do that. Oh, such simple controversies, too. I mean, just to think that, in the last 350 years, they never got around to really proving this MGH idea. That something as simple as dropping something and it having twice the velocity, and whether something with twice the velocity has twice the energy or four times the energy. I mean, that doesn't seem like a very complicated experiment. Now, the Mythbusters did do it by accident. They weren't really testing that feature, but they actually did drop a mass, from one velocity and then put two velocity. And yeah, they didn't get anywhere near twice the compression of the piece of clay or the car, for example. Nothing, not even an indication of anything more than, okay? So, but that will be ignored. And so we just have to wait until some real physicist decides to really test it and see if twice the velocity does in fact mean twice, four times the energy. It's never going to happen, I guess. Not while I'm alive. So, it's all for what? Somehow the future, like there's going to be any rational future. Like there's any hope they're going to do anything rational in the future, except run around in circles panicking. Oh, so who knows? It all seems very doomish, quite horrible, quite bleak. Fuck. Just sitting here waiting for the asteroid, frankly. There's just nothing good happening on this planet. Just nothing. I can't think of thing. I can't point to something. It's just all pretty dismal. I mean, there's some little innovations that are nice, little tools and such, but everything else sucks. All right. I just hate to even start the video because it's just all bad news. Alright, so I did do the video with the slit stuff to these different people, and apparently they just, even though their channels have like 47 subscribers and no one's paying any attention, they just don't care. They really don't want to talk about it. Okay, so my response video link was deleted off two of the channels. And the other channel, you can't even communicate with people as they have comments turned off on their videos. So, yeah, I guess there won't be any further discussion from them. Now, the fact is they did do some useful experiments, so we will keep an eye on their channels and see if they do any more useful experiments. So, and I'll just take what I can glean off of their, what they've observed and incorporate it into a more complete explanation of the double slit. So I'm grateful for their the fact that they have done experiments and provided more useful little insights. More information is always better, and so that's good. I mean, the corner thing is, like I said, I talked about the corner thing years ago, and because it really seemed a place where you'd say, yes, something's happening, because that's where there's a difference. That's where something really changes in corners and charge. Charge gets messed up on corners. So, yeah, it really is it's a feature I should have thought of. But anyway, I mean, I did think of in the past and kind of lost sight of its usefulness. And it really is quite useful, frankly. Anyway. What else? Oh, yeah, so then the, Joy douche. So I did do a little page for him, too, on the page of the shameful asswipes of physics who can't possibly, deal with a subject in a reasonable manner. Instead they just have to react with their little knee-jerky, dismissive, crap shit attitude where I'm not going to argue with you because frankly I don't have an argument. That's what it comes down to. They can't counter-argue. There's no way to counter-argue the claim that Newton was not Leibniz. I mean, it's just an absolute fact that Isaac Newton was not, God-filled Leibniz, von Leibniz. People accuse me of being vain and all these, somehow I have an ego problem. And the hero of their science, wore the biggest wigs possible, the fanciest clothes possible. And even though he wasn't a von, he insisted that people call him von Leibniz. Yeah. So ridiculous. I mean, the duplicity and hypocrisy of these people, it's just hilarious. How scummy humans are. Just scum. Speaking of that, I'll respond to some comments. Blech. Alright, I'm back. Oh, it's a struggle to deal with any of this shit. Oh, God. So this asshole, frankly, Kevin Bates. Yeah, fuck you. I just don't even know what to say about this nonsense. So I've made all these videos with all these analogies to wind, to rain, to streams, flowing streams, and even photons, flowing photons, and talked about these things with a constant forces. And the idea is that they're at a constant rate. Right? These are all things that happen at a constant rate. A certain thing happens, it keeps happening over and over again, and that's why it's called time dependent. Okay, it's because it's clearly an event that continues to happen. And the fact is the constant part means that, yeah, you can really understand it as a rate because it's not fluctuating all over the place. It's staying relatively consistent. And I have made that so absolutely clear that no fucking anal crazy motherfucker could sit there and possibly misunderstand what I'm talking about. I mean, it's really not possible. Come on. They're stupid, but they're not that stupid. And this anal nitpicky douchebag pile of shit posts this useless sack of shit nonsense on my comment section. I'm just amazed. Just an interesting addition. Interesting to what motherfucker on this planet? Somebody who's polishing their chess pieces because, it might screw up their chess game if there's a little bit of dust on their chess piece? I mean, to who could this be an interesting addition? Ken Wheeler? While I agree completely with Draft on what he is trying to explain about constant forces, I'll interject some insane nonsense that couldn't do anything but confuse anybody who's thinking about the subject. Thank you so much. I mean, that's what we needed. We needed somebody to make a whole bunch of bahoozy noises, like little, hoobies, and, march down the street and completely overwhelm the conversation. Thank you for blowing your badoozies. Shit. I can't entirely agree with his use of time, because you're insane. Okay, I get it. Time exists linguistically and exists conceptually. No, it exists as a function of the universe because the universe doesn't have anything called instantaneous speed in it. But anyway, we have to remember that time is not a thing. Well, it's an event, and it's the creator of events. Okay, so yeah, it's got both. It made water, and it made the water wet. Time makes it possible for there to be events. There couldn't be any without it. That exists on its own. Time is an emergent attribute. La 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 la. Everything, guess what? Everything is an emergent attribute. Yeah, you dumb fuck. That's the whole point of an elemental theory. Is the whole point of it is sort of describing how it's all just evolution, frankly. It all kind of has to emerge out of some pre-existing functions. And we could argue that some functions are eternal and forever. But I'd almost argue Maybe not. It doesn't. There's no rule. There's no rule. The universe can't poof an electron every 6 billion years. But whatever. So the statement all constants are time dependent. I didn't say all constants. So you can't even paraphrase me correctly? I mean, shit. Are time dependent is not true, or at least not entirely true. It's only true if well, yeah, it's always true. Yeah. Oh, come on. Just so goddamn stupid. Shadows do not exist on their own. So that's why I had Ken Wheeler in my head, right? That line right there. Shadows do not exist on their own. So shadows are so enlightening. I mean, go study shadows. Spend your whole lifetime studying a shadow. Because that's getting right to the truth, right? Oh, fuck. Let's say you put your hand out and block some sunlight. Yeah, the sunlight coming at a constant rate that's illuminating the rest of the environment constantly. At a constant rate, it's illuminating. It didn't illuminate it once, it illuminates it every millisecond. It's providing more photons to illuminate. And we're going to look at the part that you are now consuming the illumination with your hand that's now absorbing all of the illumination per millisecond. And there'll be great insight in this. Trust me, there's great insight in this bullshit. Okay. Jesus fucking Christ. It will cast a shadow. If you raise your hand higher, the shadow gets bigger. Yeah, that's the inverse square law. It actually gets bigger by 4 times. And I went over that about 176 times in my videos. I've done this. About 176 times I've done this. Fucker. Oh, I mean, God, he titled this Just an Interesting Addition. Where's the addition? Fuckface. Okay. It's not wrong to say the shadow got bigger. So, the surface area for which you are blocking the constant force at a rate got bigger. Okay. Very insightful. Or that the shadow grew larger, as long as you understand the shadow itself cannot change its size. Oh yes, we all have to explain to people that the shadow isn't an actual thing that can do anything. Just like I have to explain that the, this battery can't do anything on its own, or, this squishy thing can't shoot air out on its own. Oh, fuck. Inanimate objects can't do things, and certainly objects that are, let's just say, painted a different color can't do something special. The shadow and all its attributes, I mean, what a fucking, the shadow has attributes. Now you're the one talking shit. The shadow doesn't have any attributes. The shadow's not a thing. Okay, the shadow is an event. Emerge from the property of something else. In this case, the relationship between the surface and your hand and the sun. La 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 la. Okay, so yes, even in Draft's example with photons, there is a way to spend less time between point A and B, but still collect more photons. There isn't. It's a constant rate force. It's a constant rate force. Okay. But still collect more photons than somebody who spent more time between point A's and B's. Yeah, you're talking about going closer and further from the sun. Where was that part of this analogy? And who the fuck would care? It doesn't have any bearing on the fact that we know it's an inverse square law. We're talking about an average amount of stream flowing, and the fact is, if you fight the stream, you're going to be dragged. So you're not even accounting for that. Okay. Yes, it's more of an edge case. Oh, you're just such a fuck. But the fact that it is possible is a clear demonstration of why constant forces are not actually time dependent. It's completely time dependent based on the assumption of 9.8 meters per second. So yes, you want to be anal and say technically it's not 9.8 meters, it's 9.874644777999446222333789991 at this location. And then it's going to be that same number 2 at this location, and 3, I mean, going the other way. You fuck. I mean, adding decimal places, that's all you've done here. Okay, what relevance does it have? We're talking in every fucking example about a thing that's a constant rate through a constant blob of space. We're not talking about minutia. Useless, pointless minutia. Yes, it's more of an edge case, but the fact that it's possible is clear demonstration of why constant forces are not actually time dependent. So you can't see how that's a disgusting statement to make, that you've proven it's not a time dependent force by arguing that decimally, on the 4 billionth place, decimally, it's not exactly accurate, means it's not exactly an appropriate analogy. Go fuck yourself. Well, you probably have, indirectly, with your fingers. It's just easier, simpler, and honestly more practical for us to think it is. We're not cheating the truth by saying, look, there's an average amount of crap that passes a certain location. All right, and you have to deal with the average amount of crap. I just wanted to point, you just wanted to be an asshole because that's all you know what to do with yourself. It's constantly, your asshole is constantly talking. You have to constantly obey. I just wanted to point out, I mean, it's like, son of asshole. I just wanted to point out that, and just because something is practical and will get you the correct answer 90% of the time. No, it'll get you the correct answer 99.9999999. Yeah, you fuck. You can't even be accurate about how often the rate argument will get the correct answer. You can't even be honest about that. You want to count minutia decimal places, and yet you say something like 90% when no, it's 99.999999999. It does not mean it's true. Go fuck yourself. This is not an attack or challenge to draft. Oh, yes, it is. You're sitting here saying there's all these real conditions in the real universe that completely blow up the idea that these forces that are happening at a constant rate are time dependent. When, of course, they are. Who I have great respect for. Well, you sure as fuck aren't showing that, so I'm going to say, if you think this was a comment that would provoke anything but my disdain, you are really fucking stupid, and I'm almost insulted that somebody as stupid as you says, I have a great deal of respect for. I don't want the respect of stupid imbeciles. That doesn't make me feel any better. So shit. Fuck you again, you stupid imbecile. I just took this as an opportunity to challenge the way we think about things, because we should think about them in a totally anal way. So go out and buy a chess set and shove all the pieces up your butthole, because it's fun. God damn it, I hate this planet. What a stupid fuck. Yeah, I'm back. So there is this stupid little comment on the website I'll deal with. You say the fact that neutrons and hydrogen are almost inseparable in terms of their structure. No, I didn't say that. I'm saying they are the same thing in the sense of what they're made out of, and it's just how what they're made out of is configured. That is, how it's shaped by force. That makes the distinction. Okay, so it's elementally the same thing, And it's just that it's circumstantially different. One thing is this, and one thing is this. It's contracted. So it's like the difference between a metal and a liquid and a gas. Okay, so you could say water vapor versus liquid water versus frozen water. Same thing, different states. Okay, that would be the way to say it. Okay, where do you get that, question mark? Well, there's lots of reasons. I mean, the physics says so pretty much, okay? So they say that neutrons decay, okay, into, all right? That is, if you give them enough time to bounce around in an environment, they'll eventually settle into an electron and a proton, all right, which is pretty much the elements of what hydrogen is. So, I'd say that's a pretty good indicator. Yeah, they say another little anti-neutrino is popping out. I don't think we have to worry about that, do we? All right. You can contain hydrogen in a gas cylinder. Yeah, you can contain, frankly, you can contain anything in anything. In something. There's always something to contain anything in. The universe is containing stuff right now. All right. So, can you do this with neutrons? No, that's the whole point, is that the neutrons are in a state, okay, and I'll just explain that state. And yeah, they're hard to contain because they're moving really fast. That's the argument. They have a lot of energy, okay. It seems like another shoot from the hip, okay, so, and your crap isn't shoot from the hip crap. Regular physics isn't shooting from hips all over the place. So I don't think I'm doing anything outrageous by explaining how there is a theory of the evolution of stuff in the universe where you could explain that there's a difference between, say, an atomic nucleus inside the core of the sun and an atomic nucleus that's free out in the universe. That those are different conditions, and the different conditions mean it will basically be different. Different between the seed and the oak tree, the acorn and the oak tree. There's the difference. Okay. Feeling-based claim that you call a fact. So again, where did I say anything about any of that being facts? Okay, beyond the fact that we can argue about what physics has done some experiments to demonstrate. But so again, it's just a complete misparaphrase. I never stated that this theory is the theory, and I'm staking my whole life on this fact. This statement is true. It is exactly like this. Now, this part, okay, where I'm going to explain, okay, how charge works, because you really have to understand this part to understand any of it, frankly. All right, the simple argument I have made repeatedly, okay, that I think is, quite, it's just so illustrative. You have such a simple principle, and it does something that nobody has explained, okay, which is charge. The idea that electrons and protons are capable of producing this phenomenon, okay, where they hate each other, okay, so anything like an electron doesn't, oh, come on, Mr. Red, you can do it. Oh, don't fail me now, buddy. Come on. Cut me a break. Okay, another proton and another electron, right? And so the simple principle is that somehow the electrons hate each other, constant pressure away. Leave me alone, leave me alone. Same thing for the protons. Leave me alone, get away from me, you fucking piece of shit cunt commenter. So, and then they're attracted to each other, the opposites. And so it also explains magnetism. Magnets are doing the same thing as charge, just in a different configuration. And that's a very interesting phenomenon. And the simple rule is that if you understand that there's external pressure of two kinds, okay, that you have the same configuration, okay, you have just as you have a material element of proton and electron, you have a material element of proton force and electron force, okay, pushing things, right? Push is, again, so you could make a comment about where do you get the idea that it's a push universe? Well, because when you think about everything that happens, it all requires a push initially. Somewhere there's a push. Every pull has something pushing somewhere. Anyway, So with the simple addition to the theory that if a black thing goes into a red thing, it comes out a red thing, right? So black goes in, but red pops out. And red can either stick or reflect. So you understand that the red can only reflect, from your perspective. If it sticks, you don't see it. If it reflects, you see it come back. And so then you end up with this perfect thing that happens where and the same thing happens with the electron. If the red goes into the electron, it comes out of black. All right. And with that simple principle and the idea of understanding what push is, okay, you end up with a perfect diagram of Maxwellian diagram of charge, in the sense that you end up with protons that are doing one thing and electrons are doing something else, and you can perfectly understand why the electrons hate each other and why the protons hate each other and why they don't hate the opposites. Why it's perfectly reasonable that no red force can come this way and hit this proton. Just can't happen, because it turns into a black force if it goes through the electron. And the black force just goes through the proton, comes out a red force, doesn't push the proton. So you can understand why there's attraction, because every bit of red force coming from this direction, okay, can't affect this proton, and the proton is still being hit by this direction with the regular amount of force. So you can understand they're obviously going to be pushed into each other. So it perfectly explains charge and the mechanism. And somebody would have to, I don't think it's possible for you to find any reference where there's a simpler explanation for creating positive and negative in the sense of attraction and repulsion that perfectly matches what every experiment demonstrates charge does. It perfectly creates it. Okay, it mocks it perfectly, and it's so simple. 2 + 2. Right? It's just so simple. So you want to just mock what I'm doing is shooting from some hip or useless bullshit. You can go ahead and play that game. Okay, live with yourself. Okay, live with how little integrity you have as a human being that you would bother with such nonsense. It's clearly a great model. It fantastically duplicates a phenomenon that has mystified the best scientists for hundreds of years. So you really suck as a human being, basically. You fuck. You nasty piece of shit. All right, so now I don't think we need... we might as well bother with colors. All right, so the argument I'm making is that this phenomenon now creates another circumstance that's quite interesting. Oh, let me just get a better red. So that one just ain't cutting it. All right, it should work better. All right, so if we did have a proton, okay, and we put an electron on this side, oh dear, this really is. All right, just throw it away. Okay, do it. Just throw it away. Throw it away, Gary. Let it go. Don't try to make it do anything useful. All right, like a human, it just won't be useful. Okay, so you have this idea where, you have this interesting phenomenon where this will happen, okay, that electrons will end up getting pushed into protons and there's really nothing to push them away. And so the simple argument I would make to you that is in suns, when this thing happens, where the electrons get as close as, let's say, possible to the proton, and there's really no theoretical reason why they can't just smash right into it, that when they do that, okay, especially in a really intense gamma ray environment, right, let's just say very hot pressurized place, that what would happen is a bunch of force could end up getting collected here because there's no real way for it to get pushed out, in the sense that what needs to happen, say if an electron is moving in this direction because it collected force in this direction, a counter force can hit and knock this one off. But in this circumstance, that's not happening, so you can't really get rid of the extra pressure. So the extra pressure is stuck, okay, pushing on these electrons, pushing them into the proton. So you have a tremendous amount of energy pushing because there really isn't a mechanism for one of these little things to hit the electron this way, or one of these little things to hit the electron that way, so it doesn't lose any energy. So that's the nucleus. And the nucleus is a little tiny thing inside the very big atom, right? The atom is made of the fact that there's electrons in these different locations, and so there's a bunch of empty space, but the nucleus is very compact. And that's pretty much describing why it's very compact. And I just changed this scenario. Okay, I drew it this way, but what we kind of know is happening inside of the atom is that it's exactly the opposite configuration. Okay, there's one electron in between two protons. Okay, but it's the same, you can understand, same exact kind of scenario, right? So you have two protons and one electron, and that creates what you have in atomic nucleuses is often a 2-to-1 relationship, something close to, somewhere in the range of a 2-to-1 relationship between the number of electrons and protons. If you consider the neutron a proton and an electron, it adds up this way. So you have a plus nucleus. So the nucleus is always a positive entity. All right, net positive. Okay. And that's why the net negatives are circling it, because they're attracted to the net positive. All right, so just for the sake of the argument, let's just leave the one thing there and explain it from that idea, because they're basically the same thing. And the real trick is the protons don't move as much as electrons. They're heavier. Same size because the charge is the same, but the protons are harder to move. That's why they're in the nucleus and the electrons are on the outside. It's because the protons are heavier. So anyway, what would happen if I eliminated this? That is, I hit this with a high intensity bit of energy, all right, that displaced it, right? I wrote the wrong color. Okay, let's be technically as correct as we can be. So I have a gamma ray, let's say, a high frequency bit of energy hits this electron and knocks it this way. What's going to happen? Well, the possibility is that if it hits it hard enough, now this is free, okay? So we got a ton of energy here. And so this is now a neutron, okay? It's a proton and an electron. And it flies out of here at an intense velocity. I mean, spectacular velocity. Who knows? I mean, I can't say. 75% of the speed of light, or some kind of gigantic velocity. And it's got a big, heavy proton here. All right, and this is what's making it go, is this high pressure that you've now engaged. Now it can go somewhere, and it's going to do it. And so this fits. So you say, why do I come to these conclusions? Because this exactly fits what uranium does in a hydrogen or nuclear bomb. This is exactly what's taking place. Okay, it's these high energy neutrons. It's not just any old neutron. Okay, so decay, a chain reaction that causes a nuclear explosion, traditional nuclear explosion, is created by this very feature that you put one of these high energy neutrons, you shoot one in to an atom, so this is an atom now of uranium, and 3 new high energy neutrons pop out. So you shoot your neutron in, you break the nucleus, cause it to turn into 2 other elements with this leftover couple of pieces. So a couple of neutrons are left over, and they're high energy neutrons. They're pressurized. They were pressurized inside the nuclear oven of a sun. So they have a huge amount of energy. So it's not just that this thing ejects 3 neutrons. It ejects 3 very high energy neutrons. Energies, huge energies. All right, so that's what comes out of atoms' nucleuses, is high energy neutrons. And then you have to wait for this neutron to bang into a few things before it loses its energy. And once it loses its energy, then it does the decay part. Then it does the part where this electron and proton are no longer smashed right into each other. Okay, so you could argue that the smashing is some feature of the proton, that you're actually, this energy is actually dented like a tennis ball, the proton. And it's this energy that this energy has produced. And it's that expansion that will eventually allow this to disappear. And once it expands, then this electron can move a lot freer. The attraction is reduced. It's not stuck to the proton anymore, and can, by a minor amount of energy, be knocked away from the proton. So as soon as you get rid of this high pressure, that's sticking the two together, then the electron's a lot freer. All right. And you have what could be called a hydrogen atom, or I haven't seen the decay thing. Okay, when they say it decays into a proton and an electron, do you think the two just fly off separately? I don't think they do, because they tend to attract each other. And that's just a fact. So that, I think, makes the theory quite coherent. Okay, the idea is that when you take an electron and proton and put them in a nucleus, they're configured in one way, and when you free them, they're configured a different way. And it's perfectly consistent with what we see happen. Like I said, the nuclear chain reaction is just atoms splitting atoms, splitting atoms. You always create this 3 thing. You keep making 3 neutrons, the high energy neutrons for every high energy neutron you put in, and you're basically just making atoms smaller and smaller and smaller. And the consequence of making the atom smaller is you have a whole bunch of these things left over with a huge amount of solar pressure built into them. Yeah, I don't think I have to go much further than that. But we're talking about, again, this is a gamma ray. Saying the word gamma ray, right, doesn't mean much. This is a gamma ray that could be a quite durable gamma ray. That is, it's not going to last for a billionth of a second. It's going to last for 15 billionths, not a single billionth, but more than one. It's got quite a bit of durability in it. All right. A lot of energy. All right. I don't think I need to say more on that. These are all interesting subjects. It's okay. People, you want to say, oh, well, I'm not quite convinced, don't quite get it, go ahead, ask for more information. Tell me what part you don't really get and you don't understand, that's all fine. But to say it's crap and it doesn't fit, I mean, it's just nonsense. Of course, it actually does make sense. It does fit. There's continuity to the explanation. You want to argue little minutiae details, that's okay. You want to say something's a little irregular, that's okay. But just do it in some form where you're not dismissing that somehow you have some catastrophic flaw with that idea. Now, it's not catastrophically flawed. I have a high level of confidence that the simple answers are the right answers. I mean, they're so simple, so mechanical, that it's just almost impossible to say, how could I by chance come up with a fake theory? It's not easy to make a Sasquatch. You can't just put on any suit and it looks like Sasquatch. You have to kind of engineer a Sasquatch. How could something so simple be engineered to fake the answer? You know what I mean? To fake the answer, you usually have to do a whole bunch of contriving and nonsense. You usually can't fake the answer doing less work than the real answer, right? So whatever the real answer is, I can't imagine less details creating a viable solution. Every other solution looks like the contrived one. It looks like they were at the sewing machine diligently making their Sasquatch suit. I mean, multiverses, all kinds of bizarre ways to try to make a rational explanation. And like I said, they haven't even touched the subject of charge. They don't have any explanation. I mean, zero explanation for the existence of charge. And this simple one fits. Like a glove, frankly. It fits the facts like a glove. And I am such a super engineer that I made something so simple that answers the questions. I mean, come on. There's a high probability it's damn close to the right answer. Damn close. And you people are just, you're just being assholes, frankly. You're just being belligerently religious devotees to your little traditional notions. You just can't let it go. So anyway, enough of a video. So till the next time and such, and so forth and whatnot.